Hello guys, in this video we are going to build some code to our model called consecutive frame generation. Okay, let's begin. Let me go to my directory. Let me create a new folder called consecutive frame generation short form, and open your studio or any other editor do you love that. Create a folder called models. In that we can codes all our necessary models there. As I said, our VQVAE consists of VQVAE has the structure of encoder and some vector quantizer is a decoder, and we are stacked the unit here is a unit, and also here is a unit. We are stacking the unit here with the encoder and with the decoder. That's our plan here. Okay, let's code our unit first. Let's import the libraries. Now I'm going to copy and paste some stuff here because I can't code everything because it's a bit lengthy code. Okay, this is a class that just is a case of double count 2D and make it simple. That's it. Also, the class called down block, and then is bridge. Bridge just uses that double count class that we saw later before. And then the upblock just uses the count transpose to upscale the images. Now these classes are used to get the attention mechanism into a unit model. Now this is our final unit model here. Just as using the same code, but only the different thing is just we are using the attention mechanisms in the blocks. That's it. After that, we need to build a VQVAE model. VQVAE. Let's import the necessary libraries. Touch import NNN. Oops, it's there's a usual thing. After that, model start unit import unit. Now this class is for the VQAE. That's the residual class layers. There's some blocks of Kansuri relief block. That's it. Now this is our encoder. As you can see that this is our unit here. At top of the VQA encoder, we have the unit model, so we can perform very well. See, first we are passing the image into the unit model, and then we just are passing to the encoder. Also, I forgot one thing that now this is a vector quantizer class, just defining the embeddings, embedding dimension, beta. Now this is our decoder layer, and in decoder layer also on top of the decoder we just insert the unit here. Now this is our final VQAE. The stack of encoder pre-condensation is used to convert the H dimension to the embedding dimension, so that the ZT can pass into the vector quantizer and get converted into the space that can convert into the image by the equal decoder. The next thing we have to code for the text encoder. For the text encoder, I just copy pasted the official GPT code here, and I'll create another file called sisterpy imports. This encoder should be into the models. That should be fine. Now this is our text encoder class. We are just we just needed a cup size, embed dimension, now layers, now heads, laden shape as 64. Why the 64? I will say it later. Now we are initializing a GPT model here. So the output of this model, first the input, if you give anything like batch size, comma sequence line, batch size, comma sequence line, then it will produce the output like batch size. Will produce output like, oh shit, batch size, sequence length, and finally the embedding dimension. But we can proceed with this shape here because our plan is to, let's consider this image here. This is a VQAE encoder, and then vector quantizer, and then decoder here, and our text encoder will be here. It receives the text tokens, and these text then these text tokens are passed into the text encoder, and then it will gives us the text embedding. This text embedding is further passed into the vector quantizer. So that we needed a shape called batch size, comma embedding dimension, comma latent space, comma latent space, so that we can multiply this text embedding with our image embedding, and we can further proceed into the vector quantizer. Just taking the adaptive average pool 2D to get the desired output shape as here, and we are reshaping it into my batch size, embedding size, and the latest latent space. Now this is our final class here, final class model. Now this is our final model. Shift G, regular for cup size and the parameters here. Finally, we are initializing our text encoder that we built earlier. Now we are setting up the encoder here. That this is the VQA encoder, and these are the parts that we already seen in VQA. We are just initializing that into our final class model. First, this model accepts one image and then text. First, this model accepts one image and text. The image is first initially passed to the encoder. To encode, we get the ZE. After that, this text is passed into the text embedding, so that text encoder. So we will get the text embedding. And then the ZE is further actually in this process. The ZEs should be converted into the embedding space dimensions. That is, the shape of ZE is initially match size, comma, hidden dimension, comma, latent shape, comma, latent shape, and then this pre-quantization layer can convert this into embedding dimension, comma, latent space. That's it. And now with this, we know that already the text embedding the shape of as like this, right? B batch size, comma, embedding dimension, comma, latent dimension. So we are just multiplying the ZT and the text embedding like that, and that pass it into the vector quantizer. We will get the embedding loss ZQ, and if we pass through the ZQ into the decoder, we will get the exact. That's a reconstruct image. It's our model here. Just import the library. Now this is for creating the vocabulary class that take care of each indices words. Now this is our huge data loading process. Okay, first we have to load the CC file. Let me show this file here. This is a file. It contains the video name, and the page index, page directory, duration, content URL. We need that video ID, name, and then content URL. Right? The name has the label, the context, and then content URL has the link to that video file. So just for loading this small file here, then we have to build the vocabulary, extract the labels there, and we can build the vocabulary, get the video links, and then prepare dataset. Let me show you what the prepare dataset will do. Prepare dataset. First we are iterating through the links we have here. It is like here with all this link here. We are just at this step we are downloading the video file, and we are making the folder so that the video can convert into frames, and we can store that frames into that the directory. Then we are splitting the frames and storing in that video directory. Let me show the split frames how it works. Actually, it converts the videos into solo frames. After you downloading the videos and split into the frames, we are just calculating what are the directories we have, and then order frames. Order frames, the great job here. That is for each directory, and we are iterating through the images in the directory. Okay, let's consider this. In this folder, the first initial step at the time 0, frame 1 will be there, and then frame 2 at the time 1, at frame 3 at time 2, and so on will be there. So we are just naming the directory as it is the video name, video ID. So the frames are arranged in order of the according time steps. So we can get the comment of this video, and that's our label, and we are picking this one and this one consecutively. For index, for example, for index one of our data should be the frame one, comma the label, comma frame two. For the index one of our data, the data should contain frame 2, comma the same label for that particular container, that is directory, and then frame 3 here. Okay, and so on. So we are packing up the frame 1, comma label, comma frame 2 in upon one list. That's what we are doing here. So we are reading, sorry here. So we are reading the first frame here, and open it, number, normalizing, resizing. It's about here going on. I'm resizing into 25 comma 25 comma. This is for each frame, and also captions, and also I converting the text frames into numericals, and just storing in the frame 1, comma normalizer caption, comma frame 2. Let me show some results here. The file path is here, call path, or let's say shape, comma 0, and also let's print the labels too. Okay, hope everything's good. Now open up the timer here. I'm limiting to the 2 here because I don't want to download all the video files now. Okay, now you can see that it downloading the video frames, and also it stores the, see here, and also it stores the frames in the according folders. Now it's low. Now the data preparation finished, and you can see that the images are 256, 256, 3, and the things are the labels is like this. Okay guys, that's it for this video. In this video we seen how to create models and load data. In the next video we can actually train the model. Okay, thank you.